Hi, this is Mr. Matusiak, and I'm going to take you through the 4 classes of matter. So, what is matter? Well, anything that has mass and volume. So that means it must weigh something, and it must take up space. So almost everything that you can pick up, touch, feel, taste, that's matter. So what things are not matter? Well, your thoughts, ideas, emotions, songs, and energy. Not that they don't matter, but just about everything else is matter. Now, matter is classified by its physical and chemical properties. And so the physical properties are properties that can be observed or measured without changing the sample of matter. So color, mass, volume, density, shape, temperature, phase. We can measure all those, we can observe all those without having to change that sample of matter. Physical properties can be intensive or extensive. So intensive means that it does not depend on the size of the sample. So if the sample is red, then if it's a large sample or a small sample, it's still going to be red. If you measure the temperature and it's 27 degrees Celsius, it doesn't matter if it's large or small, it'll be 27 degrees Celsius. Now, extensive does depend on the size of the sample. So the value of an extensive property changes with the size of the sample. Now, mass. If something is larger, then it's going to have a larger mass. If it's a smaller sample, it's going to have a smaller mass. Same with volume and the amount of calories that it may contain, depending on if it's large or small again. Now, the chemical properties that we can use to classify matter are properties that can be observed when a substance undergoes a chemical reaction and gets converted into an entirely new substance. So reactivity, rusting, flammability, toxicity, those are all chemical properties. You cannot determine a chemical property simply by observing or touching the sample. It has to undergo a chemical reaction. So there's also physical and chemical changes. A physical change is just a change in appearance, but the chemical structure remains the same. So you can change the color, you can change the temperature, the phase, or you can dissolve. But during a physical change, the substance is not converted into a new substance at all. For example, let's talk about Kool-Aid, or just talk about water. Okay, so we have water, and you put some food dye in it, and it's red. Well, now you had clear water, now it's red water. It's still water. So chemical changes. Substances are converted into a completely different substance with new and unique properties that are different from the starting material. So rusting, burning, or reacting with another substance are examples of this. For example, let's say you have a piece of wood and you light it on fire, and it starts to burn. That's that chemical reaction there. When that burning is finished, you're going to have something completely different than that piece of wood that you started out with. You're going to have ashes, you might have some hot coals on there as well. So it's completely different than that piece of wood you started with at the beginning. Now, all matter can be classified as one of 4 classes: an element, a compound, a heterogeneous mixture, or a homogeneous mixture. So on this next slide, I want you to memorize the diagram, know the definitions of each term, and know 3 examples of each class of matter, and be able to classify a given sample of matter that I would give you in class. Here we go. So overall, we have matter, and to our left, we have mixtures. And mixtures are broken down into homogeneous and heterogeneous. We'll talk about those later here in a moment. And to the right, we have pure substances of elements and compounds, and we'll talk about those as well. But the bottom 4 boxes are the 4 classes of matter. Now, mixtures. So 2 or more substances put together in random proportions. That's a mixture. Now, the substances that make up the mixture, they do not react or bond with each other. And there are 2 kinds of mixtures: heterogeneous and homogeneous, just like what we saw in our diagram. A heterogeneous mixture, you can see all the different parts. Example, Italian salad dressing. Take a look at the picture. You can see the oil, you can see the chopped up herbs in there. That's a heterogeneous mixture. You've also got the example of Lucky Charms cereal. We can see the marshmallows, and we can also see the actual cereal parts. And concrete. You can take a look at the concrete picture, and you can see all the different parts, the different types of rocks that make up that concrete. If you look even closer, you might be able to also be able to see some sand. Now, homogeneous mixture, you can't see the different parts. It all looks like one thing. This is also called a solution. And you drink solutions every day. You also breathe them. Example, milk. Does a body good. Tap water and air. Now, a pure substance contains only one thing, and it cannot be broken down into anything else. There are two kinds of pure substances, elements and compounds. So, an element. Well, if you take a look at the periodic table, you can see a lot of elements. And elements are the simplest form of a matter, and about 115 elements exist. Now, these can't be broken down into anything else. The smallest piece of an element is called an atom. Now, can an atom be broken down into smaller parts? Yes, those are subatomic parts there, and we're not going to get into that right now. So, carbon, nitrogen, oxygen, those are all elements that we would see on the periodic table, and those are common elements that you should know about. Now, a compound are two or more elements that are chemically bonded in a fixed proportion and has a chemical formula. The two or more elements are chemically bonded, so they act just like one thing, so we still classify it as a pure substance. For example, carbon dioxide. Carbon and oxygen, actually two oxygen, in fixed proportions. Carbon dioxide is not CO, it's not CO3, it's not CO4, it's not C2O, it's CO2. That's carbon dioxide. And it will always act as one substance. Sodium chloride. That's just regular table salt. Now, pure substances versus mixtures. Alright, so pure substances cannot be separated into simpler components by physical means. Means you are not physically doing anything to separate it. Now, mixtures are easily separated into components by physical means. Let's take a look at how we can separate these things without doing a chemical reaction. Remember, this is all physical. So you are in some way doing this, or you are creating some type of mechanism that can do this. So distillation. So the separation is based on boiling points of these different substances that we're talking about here. And one may boil at a higher temperature than the other. And when that occurs, then you can boil off one substance and leave the other behind. And collect the boiled off substance in another flask. Filtration. Separation based on particle size. So here we are using a filter that will allow substances through depending on their size. If they are really small, they might be able to get through, but if they're too big, then they may not be able to. Crystallization, which is separation based on solubility. And we'll learn more about solubility as the year goes on. Chromatography. So chromatography uses chromatography paper, and uses a chromatography solution. And what it does is you can put a dye on this paper, and you can have this solution run up the paper, and it will separate all the different colors that make up a dye. Or maybe you're getting this dye from a pen, or maybe you're getting it from food dye from the store. And what you can do is you can separate all the different colors that make up that food dye. The last one we're going to talk about here is centrifugation, and which is separation based on density. And what it does is you put a test tube in the slots there, and it will spin and spin and spin and spin, and it will pull pieces to the bottom. And depending on their size and their density, really, it's all based on density, they will move down and create layers. You might have experienced this if you've ever had somebody hold on to your arms and just spin you around and around and around, and it feels like you're being pulled away. Well, that's it. If you have any questions, you know where to find me.